Good morning everyone. So today we are going to discuss about the topic on embedded and real-time system. So before we go for a topic, we should know about what is mean by embedded and then what are the application we have to be on embedded system. So embedded system, it is a basic things. It can be applicable for the many kind of industrials. So embedded system means it is a combination of software as well as a hardware. So it is a special purpose system designed to perform a few dedicated function, and also it has a small footprints in your memory function. The memory function, it is a mainly concern for the all kind of devices, because we have to store the large amount of files in our devices. So the main optimization should be on concern for your memory function, and also that is a code of your embedded controller. It is as highly optimized. The best example of embedded system is the cell phone as well as the MP3 player. Especially the MP3 player is a highly optimized for the storage operation, because the size of MP3 players is too small, but we can store the large size of files, and the large amount of files we can store by using a MP3 player. For the best example is there is no need of have a floating point operation in your MP3 player. So these are the application for your embedded system. So embedded, it is not only for applicable for the electronics, it can be applied for the many kind of industries, many kind of a domain. We can choose this one. So for an example, medical system. So for a medical system, many kind of medical equipment can be developed by the embedded design as well as the embedded controller only, because nowadays most of the medical equipment has been developed by the concern for low power consumption, and it should be highly optimized, and then speed also has to be increased, and then size should be an optimized one. So for this configuration, we have to satisfy this condition. We go for a embedded design system only. So likewise, they are approaching the medical system in pacemaker, patient monitoring system. Patient monitoring system, in the sense we can monitoring the old age person in on 24/7 by using some sensor. It can be optimized by the embedded controller. So the injection system as well as intensive care units. Then we'll go for the office equipment. It can be for used for the printer and then copier, even fax machines also we are controlling by the embedded system. Then tools, we'll go for the tools in the sense some kind of a multimeter, oscilloscope, even the line tester, and then GPS systems. It's also can be designed by the embedded system. Then we'll go for the banking system. It can be controlling the unit of ATM as well as the statement of printers. Then we go for the automobile industry. So the automobile industry, it's a mainly concern for many kind of automobile industry nowadays. They are developing as their in automation. So the main preference, they have to do some automation in their product. So for that only they are only prefer on the embedded design only. So once you are done in your design by your embedded controller, in the sense we can easily do our product in semi automation as well as the automation controller. Then go for the building system, as well as it is also applicable for your agriculture as well as the satellite system too. So before we go for the main topic, we should know the function between the difference between the microprocessor as well as a microcontroller. It is a main thing, because embedded, it is a fully based on your microprocessor as well as a microcontroller. We should know the basic difference between the processor as well as the controller. The microprocessor, already we have studied in microprocessor and microcontroller subject. Even though we have to know some basic things here, like a microcontroller, it has to contain additionally, it has to contain the timer counter as well as the internal RAM as well as internal ROM. Even though it is have contained the microprocessor also. This is a slightly difference between the processor as well as controller. So every units will be same only, but instead of the microprocessor and microcontroller have some additional equipments. So here you can see the difference between the microprocessor and the microcontroller. So here the microprocessor contains ALU, even general processor, register, stack pointer, program counter, as well as the timing circuit, whatever it is. But here in that addition, that we have to build in a ROM, RAM, input output devices as well as the timer and counter. We already known that timer and counter is a very important part of our microcontroller. Then it has a few instruction to move the between memory to memory and CPU. Here few instruction only. Here are many instruction as well as here few instruction only for your microcontroller. It is handling a few bit instruction. It has to many bit instruction to handling it. Then the next one is the less number of pins are multifunctional, but here the more number of pins are multifunctional. Then go for the another difference. Microprocessor based on the requires of additional hardware, but it requires a less additional hardware, because once we have set in the controller, in the sense we already designed properly and we are all invented the components efficiently. That is why it requires a less additional hardware. It is enough to controlling the whole devices. So let's go for the next one is more flexible in the design point of view. So the flexible is more designed, because microprocessor it has to given only instruction to give the to do the work. I mean it has to give the some instruction. This all of the instruction you have to do. So this all of the instruction you have to do. So it is kind of thing, the kind of devices it has to give the instruction to only for the particular devices. But here the controller, it also controlling the microprocessor and also control all over the units. So it has a less flexible only. So the system should be not complicated. Then let's go for our main topic. So this is our first topic in our subject. The first topic is a complex system and a microprocessor. So complex system means always the system should be in a complexity, okay, because whenever we go for a design, that design should be in a complex. So the first thing is embedded computer system. So the embedded computer system is a programmable computer, but it is it not itself intended to a general purpose computer. So the next thing is, I mean our personal computer, it does not need any embedded computing system, but it can use it to build some kind of a embedded computing system, which means we have a one computer, I mean our personal computer, it does not have a computing process, but it can be used to ready for the any other computing system. Likewise they are set. Then for an example, another example is a fax machine as well as a clock. That is the main thing actually. Whenever we are going to shut down our system, but our clock function is always in on, it is always in a on function only. So likewise our fax machine as well as the clock, it has like inbuilt computing the microprocessor. Then this means embedded computing system design is useful skill for many types of product design, like automobile, cell phone, even household appliances make extensive use of your microprocessor. Then the designers is many field must be able to identify where the microprocessor can be used. For an example, once they are developing a one particular devices, they have to analysis wherever we have to go applying for the such a microprocessor design to in our system or in our devices. That was they are designed by carefully. Then they go for, after that only they go for a hardware platform. Once they are done by your design, then only they can move for the hardware platform. Then if it is fixed in the sense, they can move for the hardware programming. Then after that it has to be integrated with each other, then we can producing the certain devices what we needed. Now then embedded system, it is applicable for your in many industries, it is developed by the applications as well as the equipments, components and everything we have to be designed at. For an example, when you go for the any other domain like a mechanical design or thermodynamics, it is a fundamental discipline that can be applied for many different domains. Likewise embedded also can be applied for the many domains to producing the lot of products as well as areas. Lot of products we can producing the lot of products. Then many challenges. So like while using the embedded system, we can achieve the many kind of challenges by using that embedded. It is not only for applicable for electronics, even though it can be applied for your mechanical as well as the electrical problems too. Then so this all are about your complex systems and microprocessor. That's it. Then we can go for the next topic. our next topic is embedded system design process. So is the embedded system design process basically, whenever we go for make a one device, before that we have to clarify with our design only. The first thing is we have to note our design. So the design should be inaccurate and it has been completely competency with your devices. Then only we go for to applying for your hardware things. So first thing is we mainly achieved our design process. Then only we can go for the hardware design. So for your embedded system design process aimed for two objectives. The main objectives is two main objectives. The first one is given on introduction to the various steps in embedded system design. Okay, so we have a lot of designing sector. So which kind of things we need to take for our particular kind of devices we have to develop. So we have to choose such a correct design manner. Then only we can achieve our design efficiently. Then second thing is it is allow us to consider the design methodology. So design process is apart from your to producing the product, but the main thing is that design methodology. So once we have to follow the design methodology, then only we can achieve our product efficiently, because whenever we are producing a one product, we have to satisfy our manufacturing cost. That cost is very important, because it should be in a low cost, but its performance is a high, and then low power consumption. These are the three things are very important, because whenever you are going to buy a one product or purchase your one devices, in the sense we are looking for first thing is we are looking for their cost price, then their performance. After that only we go for the some how much power it can be consumed. These are the main three things are we have to note that. For that only we go for the design methodology to optimize those performance, those function like cost, performance as well as the power consumption. So here the design methodology, we have a reason to using that. There are the three reasons we are mainly go for the design methodology. So what are the three reasons we have to using for design methodology? The first thing is it allows us to keep a scorecard designed to ensure that we have done everything we need to, like optimization performance as well as the performing functional test. So as it is I am said, whenever we go for buy a one product, we should know or we should analyze what is the performance, what are the cost, as well as what is the speed of the devices. So and so things we have to analyze it. For that, the first reason we can go for the design methodology. So next, the second methodology is, so the second reason is computer aided design. So computer aided design in the sense we are developing our product. So we are, as their customer needs, we are producing a lot of equipment as well as a lot of products, but it has to at least one time in life it has to working as semi automation or automation function. That is the main purpose we have to design the product. At least once it has to working as a semi automation, okay, or fully automation, at least in one time of their life. That is a manageable units. We can go for a second reason. Okay, so we can buy a many products, we can buy a many equipment like a medical equipment, not only the medical equipment, even the electrical, electronics, satellite systems or whatever it is, but it has to done by automation or semi-conducting. It should not be work for as a manual in all time. It has to sometime work with the semi-automation. That is the main reason we can go for the design methodology. So that is our second reason. So then go for the third reason. So third reason is the sense the design methodology is much easier for member, which means, so once we are done in our design, our teammate also convey which program we have to convey and which kind of design we are used, and then we have the following components which are flexible to designer. So those things should be understood by the third person too, because every system, if you are creating a system as a complexity in the sense, it won't be afford for the any kind of a device. So the device should be in a less complexity, and it has to be should be easily understandable to our team communicate. Now team communicate in the sense, the third person also has to understand what you are designed at. Okay, that is the three main reason we go for a design methodology. Okay, then so this is a diagram. It has to be showing the abstraction in the design process, though. So it will be conveyed on top to down design, I mean top down design as well as bottom up design. So top down design, so here it came from the top to bottom. Even the bottom up design has been shown as a curve from your system integration, then components to architecture, then architecture to the specification, then to requirements. So these are the things we have to know when we go for the design process. The first thing is the requirements, then specification, architecture, components, and then system integration. So what does mean by requirements? So whenever we go for planning for to make a one device, in the sense, what are the things we have to require, like a for the designing process, or the hardware as well as the performance, the cost, price. So we are looking for many kind of things. So before that, we have what are the things we need to require. Okay, we have to analyze that specification. Then what kind of devices we are going to applying for this kind of particular component. So what are the particular component we have to design for this kind of devices. Okay, so that is a specification, like a version, and then your size, it's applicable to it. Then architecture, that architecture means, and then less complexity design. Then components, so what are the components we have to be indented. Then system integration, the main part is after satisfied our fourth thing, we can go for the integration part. Integrate in the sense, we have to integrate all over the specifications. Then so here I told you top down design as well as the bottom up design. So here the top down design will begin for the most abstract description from the system. So that is a system that has been abstracted from your top down design. Then bottom up design, it is a slightly do not have a perfect insight into the later stages. The design process will be turned off by using of your bottom up design. So why we go for the top down design as well as the bottom up design? So we have to satisfy some questions, like how fast can we make a particular function run. So whenever we completed our design or completed our products, they are asking some other questions, like this all are the question may raised. These are the 4 questions are important to analyze their product. The first thing is, how fast can we make a particular function has to be done. Then second, how much memory will we need. So the main thing is a memory function. The third one is, how much system bus capacity do we need. Then the fourth one is, if our estimates are inadequate, then we may have to backtrack and amend our original decision to take a new few facts into our account. Because once we are done in our design, once we are done in our component side, and when we are done in your product design too, some kind of things we need to we get some inadequate product. Likewise, we have to go for some backtrack technique to get into the original system. Then these are the major goal of your design. So as it is, I am said, whenever we go for a buy one product, we have to analyze the manufacturing cost as well as performance, even though your power consumption. Okay, so then at final, the following design process we need to perform for each single step. So whenever you go for the design process, that the design methodology is separate one, but this is here we are going to analyze the design process. So when you are going to analyze the design process, it can be following by the 3 conditions. These are the main 3 sector we have to known for your design process. This each single step it has to perform in your design process. The first thing is we must analyze the design at each step to determine how we can meet the specifications. Then second one is we must then refine the design to add the details. Then third one is we must verify the design to ensure that it still meets all the system goals such as cost, speed and so on. So as we discussed in earlier, like whenever we go for one product, we have to analyze some kind of specifications, some kind of a performance thing, and then cost, and then power consumption. Everything it has been solved by using the single step. It has to be performed for your all over the design process. So this is all about your embedded system design process. So today we are discussed two topics. Okay, the first thing is complex systems for embedded computing. Then second is the embedded design process. So in the next topic we will see on the next classes. Thank you.